Effectiveness test. Tests have been conducted to show how photocatalytic oxidizers decomposes existing mold. This 8-week test was conducted on existing mold on the side of a building. As time progresses, the mold is decomposed and is washed away by rainwater. Another test performed on organic dye applied to PCO treated tiles show how effective PCOs are over a short period of time. Self-cleaning properties. Superhydrophilic properties. Another added benefit that PCOs produce is the ability to make water superhydrophilic. On conventional surfaces, water tends to bead on surfaces. When this happens, the beaded water may not drain from the surface, and the standing water collects pollutants. When the water dries, the pollutants remain, leaving dirty spots on the surface. On PCO-treated surfaces, water becomes superhydrophilic, meaning that it does not bead, but creates a thin sheet of water that flows across the treated surface. As the water sheet flows, it lifts dirt from the surface, resulting in a clean surface. Looking at the surface from a profile perspective, we can see that the PCO allows water to flow under dirt, lifting it away from the surface along with the water to drain. Photocatalytic oxidizers also work well on glass and mirrors. When water condenses on glass, it forms tiny drops, or fog, that make the surface difficult to see through. With the superhydrophilic property of PCOs, glass remains fog-free. Air quality. Indoor air quality. Indoor pollution sources that release gases or particles into the air are the primary cause of indoor air quality problems in buildings. Inadequate ventilation can increase indoor pollutant levels by not bringing in enough outdoor air to dilute emissions from indoor sources and by not carrying indoor air pollutants out of a building. High temperature and humidity levels can also increase concentrations of some pollutants. There are many sources of indoor air pollution in any building. These include combustion sources such as oil, gas, wood, and tobacco products, building materials and furnishings, asbestos containing insulation, wet or damp carpet, and cabinetry or furniture made of certain pressed wood products. Products for household, cleaning and maintenance, personal care, or hobbies, central heating and cooling systems and humidification devices, and outdoor air pollution. Volatile organic compounds, or VOCs, from sources such as building materials and furnishings release pollutants continuously. Other sources related to activities carried out in the home release pollutants intermittently, such as smoking, the use of unvented or malfunctioning stoves, furnaces or space heaters, paint and paint strippers, and the use of cleaning products and pesticides in housekeeping. VOC concentrations can remain in the air for long periods after some of these activities. Health effects from indoor air pollutants may be experienced soon after exposure or possibly years later. Immediate effects may show up after a single exposure or repeated exposures. These include irritation of the eyes, nose, and throat, headaches, dizziness, and fatigue. Such immediate effects are usually short-term and treatable. Sometimes the treatment is simply eliminating the person's exposure to the source of the pollution if it can be identified. Symptoms of these diseases, including asthma, may also show up soon after exposure to some indoor air pollutants. Other health effects may show up either years after exposure has occurred or only after a long or repeated periods of exposure. These effects, which include some respiratory diseases, heart disease, and cancer, can be severely debilitating or fatal. It is prudent to try to improve the indoor air quality in a building, even if symptoms are not noticeable, as it is one of the top 5 health concerns in the U.S. according to the Environmental Protection Agency. Odor and VOC decomposition rate. Tests on odor and VOC decomposition rates further shows the effectiveness of photocatalytic oxidizers. The following common VOCs, or odor-causing chemicals, were tested for decomposition on a PCO-treated surface. Ammonia is completely reduced to nitrogen and water over a period of 90 minutes. Ethylene is completely reduced to carbon dioxide and water over a period of 160 minutes. Formaldehyde is completely reduced to carbon dioxide and water over a period of 90 minutes. And vegetable oil odor is completely reduced to zero over a period of 10 hours. NOx removal. NOx is a generic name for a group of highly reactive gases that contain varying amounts of nitrogen oxide and nitrogen dioxide and is colorless and odorless. The major sources of NOx are motor vehicles, electric utilities, and industrial, commercial, and residential combustion emissions. When NOx and volatile organic compounds react in the presence of sunlight, they form photochemical smog, a significant form of air pollution, especially in the summer. Children, people with lung diseases such as asthma, and people who work or exercise outside are susceptible to adverse effects of smog, such as damage to lung tissue and reduction in lung function. Photocatalytic oxidizers degrade NOx on its surface, leaving the surface clean. NOx elimination effectiveness test. Testing of a photocatalytic oxidizer was performed on a precast building panel in an urbanized area. The right side of the panel was treated once with a PCO, while the left side remained untreated. After a 4-year test period, the right side of the panel remains clean of pollutants, while the left side has become tainted with pollutants from industry and vehicular emissions. NOx elimination. The process in which PCOs eliminate NOx can be compared to how trees clean our air. 1,200 square yards of treated surface has an air purification capability equivalent to 70 deciduous trees. Applications and benefits. Application methods. Photocatalytic oxidizers can be installed directly into product during the manufacturing process. Currently, PCOs can be applied to ceramic tiles using this method. With this process, lifespan of the PCO is as long as the lifespan of the tile. Photocatalytic oxidizers can be installed onto product after the manufacturing process. PCOs that cannot be installed into products during the manufacturing process may be installed via different techniques such as spraying and dipping methods. With these processes, the lifespan of the PCO will be temporary, usually lasting between 5 to 10 years. Applications for photocatalytic oxidizers. Now that the properties of photocatalytic oxidizers have been reviewed, where can they be applied? Proven application locations for PCOs include areas of health and healthcare areas, such as hospitals, assisted living facilities, and medical office buildings. Transportation and the public sectors, such as airports, mass transit stations, and tunnels. Fitness and wellness areas, such as pools, spas, and saunas. Building facades, including rain screens. Shopping and business areas, including shopping malls and office buildings. And residences in kitchens and baths. Application locations of PCOs is virtually unlimited. Because photocatalytic oxidizers act as a UV protectant, they may be applied to exterior surfaces such as paint, concrete, glass, roof, stone, wood, plastic, metal, and water features. They may be applied to interior surfaces such as walls, tile, fabrics, mirrors, kitchens, and bathrooms. PCOs can be used on the interior of cars to help keep them odor-free. This concludes this AIA CES presentation on photocatalytic oxidation coatings. Thank you for your time.